On this question, we have a simplified equation. It's simple. There is no distributive property to do, no combining like terms. Both sides, the left side and the right side, are simple. And what I do with the equations, I always pretend that there's like an invisible wall. I always draw a line, so you could pretend that there's like a wall separating the left side from the right side. And what I've seen some students do is they're so used to getting the x to the left side, like they move it over. You could get rid of that minus 2x by doing the opposite. Now, I wouldn't do that, but I've seen some students do this. Plus 2x plus 2x, they end up with 5x minus 9, and then they don't know what else to do because they moved everything to the left. But the reality is, if you did move that negative 2x to the left by doing the opposite, if you got rid of it, then what's left on this side? Absolutely nothing. So you must continue with the number 0 right there. And then you would get the 9 by itself, or the 5x by itself. You would get rid of that minus 9 by doing the opposite, plus 9, plus 9. Then you'd end up with 5x equaling 9. And then you would get rid of that multiplication of 5 in front of the x by dividing by 5 and dividing by 5. And that would be your answer, x equals 9/5. Of course, you could change that to a mixed number, but that's good enough. I saw a lot of students move this over and have nothing left, and then they got stuck. They put no solution. I don't know. So let's clear that up, that if you do end up with nothing on the right side, you have to put 0 right there and continue solving. Um, how would I have done this problem? I would have, let me rewrite this. I would have gotten the x, since I have x's on both sides. You have x on the left side of the equal sign, x on the right side. I would have simply gotten the 3x over there. And then rewriting this thing, again, here's my wall. I'd have a negative 9 equals negative 5x. Then I would divide both sides by negative 5. And you'd get your answer. That cancels out. X equals 9/5, because a negative divided by a negative is a positive. Anyways, that was a simple one. I hope you guys understand it. If you were like, oh, I'm kind of confused about that, hopefully you copied notes down and now you get it. Let's take a look at this next one. It's also simplified, but it has a fraction in it, right? Not only that, there's variables on both sides. There's x's on both sides. So if you chose to get rid of the fraction first, there's many roads to the same place, but if you chose to get rid of the fraction first, you'd have to multiply everything by the denominator of the fraction that you want to get rid of. Once again, a fraction is the division problem, 2 divided by 3. So if you don't want this divided by 3, if you would want that divided by 3 to disappear, you'd have to get rid of it by doing the opposite. I mean, we could all agree that 2x is better than 2. So if you wanted to get rid of that divided by 3, you would simply do the opposite, which is multiplying by 3. Now, you can't just multiply one single item on an equation by 3. You have to multiply everything on the equation by 3. As long as what you do to one side, do to the other. So everything on the left side, everything on the right side. So you're going to multiply by 3. You're going to multiply by 3 here, multiply by 3 here, multiply by 3 here. Now, the 3's do cancel out. What do I have left? I have a 2x, no more fraction, plus 6 equals 3x minus 24. Okay. Now from here, you already got rid of the fraction. Now you want to get x by itself on one side. And where's x at? Is it on the left side of this equal sign or the right side of this equal sign? It's clearly on both sides. You have 2 x's here and 3 x's there. You don't want x's on both sides. So let's get rid of one of them. I want to get rid of that 3x by subtracting it. You could have chose to move the 2x to the other side, but I just moved the 3x to the left side. And 2x take away 3x, that will be a negative 1x. And I'm going to bring down the 6, bring down the equal sign, and bring down the minus 24. So there's my new, smaller, simpler equation with only an x on one side. So now let's worry about getting this x by itself on the left side. Obviously, we want to get rid of the 6 first before the multiplication of negative 1. So let's get rid of that 6 by doing the opposite. Minus 6 cancels out, minus 6. Bring down what's left on the left side of the equal sign, which is a negative 1x. What's left on the right side? Well, if you do negative 24 minus 6, you could do it on a calculator, or you could think of money. You owe 24, you owe 6, you're going to owe a total of 30. Now for your final step, you want to get rid of this multiplication. Whoops, 30. You want to get rid of that multiplication of -1 by dividing by -1. How do you get rid of multiplication? With division. And remember, division is really just a fraction bar. So you're going to divide by -1 on both sides to keep the equality. And yes, that cancels out. And yes, your answer is x equals positive 30. So I hope we all understand that if you ever have a fraction in an equation, you could get rid of it by multiplying everything by the denominator of that fraction that you want to get rid of. Okay. I apologize for those of you that already understand this. What if you have multiple fractions and you want to get rid of all of them at the same time? You could get rid of them, one of them at a time, like by multiplying by 4 or multiplying by 6 or multiplying by 8. But you could get rid of all of them at the same time if you simply take a moment and think of the LCD of 4, 6, and 8. Okay. So first, look at the biggest number, and maybe 8 is the LCD. So 8, could you change 4 to become 8? Yeah, 4 times 2 is 8. So you're pretty happy right now. Maybe 8's the LCD. But then 6 times what gives you 8? It doesn't work. So 8's definitely not the LCD. But you still go with the biggest denominator and checks. Maybe it is the LCD. Now, if we realize that it's not, like we just did, we're going to take that 8 and multiply it by 2. 8 times 2 is 16. Could you change 4 to become 16? Heck yes. Could you change 6 to become 16? No, it can't. So 16 is not the LCD either. How about 8 times 3? That's 24. Could you change 4 to become 24? Yes. Could you change 6 to become 24? Yes. So the LCD is 24. LCD is 24. Okay. So we could get rid of all fractions at the same time if we multiply everything by 24. So we're going to put this times 24, this times 24, this times 24. And notice that whenever you multiply a fraction with a number, I put that number in the numerator position, not at the bottom. It's up here. That way, when you look at it, it says 24 divided by 4, and 24 divided by 4 is 6. Um, if you're confused with this, you could simply get a calculator and go 24 times a fraction 1/4. It'll give you the final answer, which will be 6. Right here, it's 6 times 1 gave us 6. And then you have the plus sign. And then over here, 24 divided by 6, that is 4. So then you're going to multiply 5 times 4. That'll give you 20. And of course, you have this x with that 20. Again, if you're confused with that, simply get a calculator, type in the fraction 5/6, and then hit times 24, and it'll give you the answer 20. Okay, it'll give you the answer 20. And then just put the x on it. Again, if you're confused with this, get a calculator and do 3/8 times 24, and it'll give you your final answer with the calculator. But I think it's pretty simple. If you know your division, 24 divided by 8 is 3, and then 3 times 3 is 9. So here's your new equation without fractions. Now you could get x by itself on one side. Now, I purposely made all these equations to end up with fractions, ugly answers, because a lot of times you guys freak out like, oh, why isn't the answer 3 or -2? It's possible that you get fractions as answers, which are technically decimals also. Anyway, let's continue by isolating the x on the left side of this equal sign. So here are my two sides, the left side and the right side of that equal sign. Let's get it by itself. Let's get this x by itself. So we're going to get rid of the 6 first. And then we're going to rewrite this thing 20x equals 3. And for my final step, what do I really have here? I have 20 times x. It doesn't say 20 plus x or 20 minus x. It says 20 times x. So I want to get rid of that multiplication by doing the opposite of multiplication, which is division, that fraction bar. And you want to get rid of the 20, not the x. You only want to get rid of the 20. So that's why you divide only by 20, not by 20x. That cancels, that cancels. And of course, what you do to one side, do to the other side, divide by 20 over here. And that will be your final answer. X equals 3/20. What do you guys think? So anytime you have a fraction, don't get freaked out. You could get rid of any fraction or all fractions at the same time simply by multiplying by the LCD. Okay. What about if we had a fraction, but then there's parentheses where the fraction is supposed to be distributed in? Well, you could get rid of the fraction right from the start, or you could actually distribute 2/3 times x. It would be 2/3 x. 2/3 times 5. You could do that with a calculator. It'll be 10/3. Or you could just get rid of the fraction right from the start. Wouldn't it be easier if this problem just said 2 parentheses x plus 5, where you just distribute the 2? It'd be a lot easier. So instead of distributing the 2/3, which you could do if you want, I'm going to get rid of the fraction by multiplying everything by the denominator of the fraction that I want to get rid of. So I want to multiply by 3. That way it cancels. Multiply by 3, multiply by 3, multiply everything by 3. Now, some of us are thinking, wait a minute, how come you didn't multiply the inside by 3? Because whatever I do to this outside term, that has to be distributed. Whatever I do to that outside term that has to be distributed, it's like if I did it to the inside terms. So by me multiplying this fraction by 3, it's like multiplying everything by 3. So don't multiply by 3 here or there. That would be incorrect. So it's kind of like if the parentheses are protecting these guys from being multiplied. I hope that makes sense. So what do we really have here? We have a 2 parenthesis x plus 5 equals 3x minus 12. And then you could go about your business simplifying each side. The right side is already simple. Let me draw my line. The left side is, I need to distribute to make it simple. 2 times x, 2x, 2 times 5, 10. And we might as well put that positive sign because it's a positive 10. We still have the equal sign. On the left side, we have a 3x minus 12. Now that it's simplified, now we could worry about getting x by itself on one side. So where's the x at? Is it on the left side of the equal sign or the right side? It's on both sides of this equal sign. So let's get rid of one of them. This time I'm going to choose, just to be a little different, subtract 2x and move it to the right. So what do I have left? I have a 10 on this side. I have the equal sign. I have 3 take away 2, which is 1. That's simply a 1x, or just an x, and then the minus 12. For my final step, I want to get rid of that minus 12 by doing the opposite of minus 12, which is plus 12. What I do to one side, I do to the other. And there is my answer. 22 equals x. X equals 22. Are we cool with that? Now, there's this one challenging question, but I hope we've built up to it. And we could solve this problem in different ways. Let's start by, I don't know, do you guys want to eliminate all fractions at the same time? Or do you guys want to get rid of one fraction at a time? What do you think? All at the same time. So for that, you'd need an LCD. So what's the LCD of 8, 4, and 6? 24. Once again, go to the biggest number, see if the other ones could change to become 8. 4 times 2 is 8, but 6 times 2 is not 8. Then double it, that's 16. 4 times 4 is 16, but 6 times nothing will give you 16, right? So, well, will not give you 16. 6 times anything will not give you 16. So then you triple it, 24, that could change 24, that could change 24. So the LCD is 24. So we're going to multiply everything by 24, everything by 24. This negative 1 times 24, this fraction times 24, this fraction times 24, this fraction times 24, everything by 24. Once again, the parentheses kind of protect the inside, so you don't have to multiply by 24 right there, because whatever you do to the outside guy, it's like if you did it to the inside guys because of distributive property. Anyway, what do we have here? We have a negative 24 because 24 times negative 1, that's negative 24. We have 24 divided by 8. 24 divided by 8 is 3. So what we really have here is 3 times negative 3. And 3 times negative 3 is a negative 9. And you still have the parentheses x minus 3. Then over here, 24 divided by 4, that's 6. So you really have 6 times the negative 1x. 6 times a negative 1x. That would be a negative 6x. And of course, we have the equal sign that separates the sides. So once again, we said 6 times negative 1x is negative 6x. And then last but not least, 24 divided by 6 is 4. And 1 times 4 is 4. So we got rid of all fractions at the same time by multiplying everything by the LCD. And now we could worry about simplifying each side and getting x by itself on one side. So the right side, there is no distributive property. You can't combine like terms because they're not alike. On the left side, you could distribute the negative 9, and that's what you should start with. Negative 9 times x is negative 9x. Negative 9 times negative 3 is positive 27. And then you could bring down that minus 24. So we have distributed the -9. Now we have 1, 2, 3 terms. Out of those 3 terms, we could combine the numbers with the numbers. The -24 plus 27, if you owe $24 and you have $27, you could completely pay them off and you'll still have $3 left over. So you have -9x with $3 left over. And now you have the equal sign, bring down the -6x plus 4. It's now a simple equation. There's nothing else to do to simplify it. Now we could worry about getting x by itself on one side. Where's the x at? Is it on the left side or the right side? It's on both sides. You got a -9x and a -6x. So it's up to you if you want to move this guy to the right or this guy to the left, whatever you guys prefer. I want to go with the -9x. I want to move it over here. That way it becomes a positive x. So I want to get rid of the -9x by doing the opposite. Plus 9x cancels out. Plus 9x. That will be 3x. Bring down the plus 4. Bring down the equal sign. Bring down the 3. Now we want to get x by itself on the right side. So let's get rid of the 4 by subtracting 4. We do to one side, do to the other. Subtract 4 over here. You're going to end up with a -1 equals 3x, which really means -1 equals 3 times x. And the way to get rid of multiplication is division. And when you do to one side, do to the other. That way the 3's cancel out. And you have your answer right there. -1/3 equals x. But the better answer would be x equals -1/3. I hope you get it.